The part of the working memory system that deals with visuospatial information is called the Visuospatial Sketchpad. And this holds information visually and spatially, and it codes it in sort of those terms. So whenever you're doing something visual, be it imagining walking through a space, doing a puzzle, drawing something, any of that actually will involve your Visuospatial Sketchpad. Now again, it's important that we don't just propose components of models, but we actually have some ways of testing them. Now, here's the first study that actually gives good evidence that this Visuospatial Sketchpad is something that's really existing. And what happened in this particular study is that people were asked to do this very strange task where they essentially had to trace the outside of letters as they mentally traveled around the border of the letter. And at each corner, with their eyes closed, they had to say or point to yes if they were still at the top part, or no if they were no longer at the top part. What I mean by that is this: imagine that you're a little ball and you start at the top of the letter F. You start traveling and you reach a corner and you're still at the top part of the letter, so you'd say yes. Then you go to this corner, you would still say yes. You go to this corner, you still say yes. Now you travel down here and you would say no, 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 yes, 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 no, 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 and so forth. So that's the task. People have to do this mental task, this visuospatial task, and then give these responses. Now what's interesting is that in this task, they actually manipulated the way in which people were responding to where they were on the letter. In one condition, they did exactly what I just did, which was the speaking condition. They would just say yes or no. In the other condition, they had on a blackboard, on the left side they had the word yes, and on the right side they had the word no. And people in that case just had to point to either the left or the right, depending on whether the answer was yes or no. Now, that's an important manipulation that's meaningful because pointing is a visuospatial task. So that task would involve the Visuospatial Sketchpad. Speaking is handled by the phonological loop, so that's a separate system. So that shouldn't really have sort of the same level of difficulty as pointing would in this particular task. If we now look at how long it takes people on average to complete a full circle around the letter F when they're speaking versus pointing, you indeed see that pointing was a lot harder here, to people a lot longer. And the idea is because this pointing task uses the Visuospatial Sketchpad, while the traveling the F task also uses the Visuospatial Sketchpad. So this is a really nice study. In some ways, it's of course a pretty artificial task, but it gives evidence for two parts. First of all, it provides nice evidence that the Visuospatial Sketchpad seems to exist. Second, it also provides nice evidence that the phonological loop and the Visuospatial Sketchpad seem to have their own limited capacities. You can combine two tasks just fine, or two ways of processing information and responding just fine, if one of them involves the phonological loop and the other one involves the Visuospatial Sketchpad. However, if they both involve the same component, it's not impossible to do it, but it becomes a lot more difficult. So that's the first study that gives some evidence for this Visuospatial Sketchpad idea. Now, in the second study, they also used a clever manipulation to get at this. And if you thought the previous task was strange, this task was even stranger. So let me walk you through what happened here. In this study, they asked people to basically subtract two visual images from each other. And what I mean by that is this. In some case, they would actually see a picture like this. Sorry, this got out of alignment. They were given this image, and then they were asked to subtract this shape right here from this picture of a candy, right? And they would get this image first, so that they would think, oh, it's either the shape of a candy, or they would just translate it into the word candy. And then in the second step, they were given this image that they then had to subtract. Now, the answer in this case is it's a fish, but you can really only do that if you kept a visual code of this image over here. Imagine if you saw this image of candy and actually processed it through your phonological loop. In that case, you're really screwed because now you have the word candy activated, and then in the next step you're being asked to subtract some visual shape from a word, which will not work very well, right? So in this case, really, the better option is to code this in on the Visuospatial Sketchpad. Then you can actually perform this task and you can realize, oh, the remaining picture would look like a fish. So that's the task. Now there's one additional thing that's really interesting in this study that they did. And that was that in one group, they actually managed to block the phonological loop by giving people a secondary task that involved the phonological loop. So in one group, they were told, while you're doing this task, you have to go la 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 the whole time. And the point of that was to prevent people from using the phonological loop to code this picture as the word candy. What they then did was look at whether people could perform this task more successfully if they just got the picture and had to do the subtraction, or if they were better off getting the secondary task, which blocked the phonological loop. Because the phonological loop being not useful in this task, that would actually be a good thing. So then based on that, performance in the group that had the secondary task should actually be better than in the group that didn't have the secondary task and was just given the pictures. And that is exactly what they found. So in this case, giving people a secondary task actually helped their performance because it made that people did not code this image of candy as the word candy and were then unable to perform the subtraction. So I like that study because in some ways it's confusing, but it provides very strong evidence that this phonological coding and Visuospatial Sketchpad coding is really something that happens, and that actually by separating tasks to deal with the two different components, people can actually perform better than if you kind of leave it unspecified in which way the system should handle this. Now that gets me to the last part about this system, which is how do different tasks get thrown onto either the phonological loop or the Visuospatial Sketchpad? Well, that's that thing in the middle that's called the central executive. So the central executive is an interesting thing, and we'll talk about that more when we literally talk about executive processing, because that warrants actually a whole module. Executive processes are manifold, and they involve regulating our behaviors, sequencing our behaviors, generally controlling what we're up to in the world. So the central executive is a form of that. It's a controller. It can access long-term memory to activate information in long-term memory. It can actually send tasks to either the phonological loop or the Visuospatial Sketchpads. It can focus on specific aspects of the task, and it also can switch attention between different parts of the task and back and forth. It takes information from both systems, the phonological loop and Visuospatial Sketchpad, and then integrates it so that people can actually act upon the world in a successful way. So what's interesting about that system is that it's actually modality free. The central executive is neither auditory nor visual, right? It just depends on where it sends the information. It's kind of like our attentional system, and it manages to deal with cognitively challenging tasks. It knows, quote unquote, where to send particular tasks depending on whether certain capacity is already being used for something else or not. So we'll also see later on when we talk about executive processes that this is closely related to how well your frontal lobe functions. And we'll also see that the frontal lobe in general is actually where a lot of aspects related to personality as well as social functioning take place.